We are looking at midpoint of a chord, and we want to prove a theorem here that a straight line drawn from the center of a circle to bisect a chord, which is not a diameter, is at right angle to the chord. Remember, the last time we talked about a chord, I told you that a chord is not a diameter. I told you that a chord is not a diameter. So today we want to look at a straight line drawn from the center of a chord to from center of a circle to bisect a chord which is not a diameter, is at right angle to the chord. Now we say given a circle with center O and a chord of line AB. This is a chord of line AB. Now, draw a line from O to meet line AB. We call here N. Now, this line that is drawn to meet line AB forms what is called a perpendicular angle. So, we say that line ON is perpendicular to line AN. And we say perpendicular line are lines drawn to meet another line that forms a right angle. So we say here that this particular point from this place to this place is an angle of 90 degrees. This is a right angle. From this point is a right angle of 90 degrees. Here too is an angle of 90 degrees. Now we say, remember I told you that a perpendicular line is formed when a line meets another line to form an angle of 90 degrees, to form a right angle triangle. Now, a right angle is an angle of 90 degrees. That is to say that this angle here, BMO, is an angle of 90 degrees, which is a right angle. BMO, this angle here is 90 degrees, it is a right angle. And also, AMO is also another right angle, which is an angle of 90 degrees. That is to say that BMO is equal to AMO. Now, when we add these two angles, BMO plus AMO, these two angles will give us 180 degrees. Why? Because angle on a straight line is equal to 180 degrees. That is, from this point, this angle here, 90 degrees plus 90 degrees, will give us angle of 180 degrees. Now, we should also take note that line AM, which is from this point to this point, is equal to line MB, which is from this line to this line. That is to say, if line AM is 2 cm, therefore line BM will also be what? 2 cm. So this line AM and line MB is equal, which means they are equal line. Whatever you have here, whatever cm you have here, will still give you the same cm here. Now, if we draw a point, if we draw a line from this our center O to meet B, you see that an angle will be formed. And this angle that is formed will become a right angle triangle. A triangle will be formed. This triangle now, we'll call it a right angle triangle. A triangle of 90 degrees. Now, when we draw another line from this our center O to meet this other point A, another triangle is formed. Now, this line we draw here is called radius. And this other line is also called radius. Now, the two of them are called radar. Now, we say that, remember, this is our center O. So, we can say that our line OA is equal to line OB, which is the radar. Line OA is equal to line OB, which is what? The radar. So, whatever angle we get here will be equal to the angle we get here. If here gives us 5 cm, it means that here will also be what? 5 cm. So when you look at this, you will see see that we have proved this theorem that a straight line drawn from the center of a circle to bisect a chord, that is called of line A, will form a right angle, which is an angle of 90 degrees. So if you see what we have done here, that okay, we are going to be looking at these examples on, remember we just did midpoint of a chord. So we'll be looking at these examples. The question says the radius of a circle is 10 cm. The length of a chord of the circle is 16 cm. Calculate the distance of the chord from the center of the circle. Now, solution. The first thing we do, we draw the circle. This is the circle. This is the chord. Remember, there is a chord there. Or let's call it AB. Let's call the chord A. Now, they say that the chord, the length of the chord, that is from this point to this point, is 16 cm. Length of chord, line AB is equal to 16 cm. That is from this point to this point. Now, they say calculate the distance of the chord from the center. If we read the question from the beginning, the radius of a circle is 10 cm. And this is the radius, which is 10 cm. From this point to this point is also a radius, which is 10 cm. Remember, in our initial proof, we say that line OA is equal to line OB, which is equal to what? 10 cm. So the radius given to us is 10 cm. And then we are asked to find the distance of the chord from the center. That is the distance from this center to this point. That is what we are looking for. Now here is, let's call here M. Remember that our chord, the length of our chord is given as what? 16 cm. But we need to get our length. We need to get AM. We need to get from this point to this place. So how do we do it? Now know that this chord here, this line here, bisects this chord into two equal parts. If you look at it, the line bisects the chord into two equal parts. So therefore, if this line bisects it into two equal parts, it means that our AM, which is equal to BM, is equal to line AB divided by 2. That is, this line, this chord here, divided by 2 will give us our AM. And our line AB is giving us what? 16 cm. So it therefore means that our AM, which is equal to BM, is equal to 16 divided by 2, which will give us 8 cm. So here we say that our line AM is equal to line MB, or you can call it BM, which is equal to 8 cm. So that is to say that here is equal to 8 cm and here is equal to 8 cm. Now remember, initially I said that once this line is drawn from this center O to touch this point here, that a triangle is formed, and the name of this triangle that is formed is a right angle triangle. Now this is a right angle triangle. This part of it is also a right angle triangle, and we are asked to find this side. Let's call here X. Now to find the side of a right angle triangle, we use Pythagoras theorem. And this Pythagoras theorem says that the hypotenuse square is equal to opposite square plus adjacent square. That is what this Pythagoras theorem states, that the hypotenuse side, which is the longest side of the right angle, is equal to the sum of the square of the other two sides of the triangle. Now our hypotenuse is given as 10 cm. The hypotenuse is 10 cm. So we put 10 squared is equal to the opposite. Let's call here opposite. The opposite is x. It is not given, x squared. Plus the adjacent is given as what? 8 squared. So this will give us 100 is equal to x squared plus 64. So we want to make x subject of formula. Making x square subject of formula in first, we have that x square is equal to 100 minus 64. So our x square is equal to 36. Therefore, x is equal to square root of 36. X is equal to square root of 36. And square root of 36 is equal to 6. So our x, which is our line OM, is equal to 6 cm. That is to say that this line here is 6 cm. So we state that our line OM is equal to 6 cm. So we are going to be looking at the second example. But before we do that, if you have any question on this particular topic, you can type it, you can send it through the comment section, and we'll get it and solve it. Look at example number 2. Example 2. The distance of a chord of a circle of radius 5 cm from the center of the circle is 4 cm. Calculate the length of the chord. Calculate the length of the chord. Now we start, remember, we always start with our circle. Because what we are talking about here is circle. The distance of a chord from the center of a circle of radius 5 cm from the center of the circle is 4 cm. Now let's put our chord first. This is our chord AB. Now the distance from the center of the circle to the chord, we say it is 4 cm. So here is 4 cm. And then the radius is 5 cm. Remember, we read the question very well and we understand it. So this point is what? 5 cm. Here we'll call here our M. This is our O, which is the center. So this is the question. We are asked to calculate the length of the chord. The length of the chord is not given. That is what we want to calculate. The distance from the chord to the center of the circle has been given. Sorry, the distance from the center to the chord has been given. The radius is given as 5 cm. So we come here, we say that our line OB, which is the radius, is equal to 5 cm. Line OM, which is the length, which is the distance from the center to the chord, is 4 cm. Now we are asked to find line MB. Line MB is not given. I'll call it X. So line MB is not given. It's equal to X, not given. Now, just like we said, when you look at this triangle here, you will see that this part of the triangle is a right angle triangle, and it is an angle, a right angle triangle with an angle of 90 degrees. And then to find the side of a right angle triangle, we use Pythagoras theorem. Just like I said earlier, we use Pythagoras theorem. Pythagoras theorem says that the hypotenuse square is equal to the opposite square plus the adjacent square. That the hypotenuse square is equal to the opposite square plus the adjacent square. Now we look at this, our triangle here. We are looking at this side. You can still look at this side. Whatever applies to this side of the triangle also applies to this side. They are all the same. Because from our initial theory, we said that OA is equal to OB. So whatever we do here, whatever we apply here, it is the same thing. Now, our hypotenuse is 5 cm. Our hypotenuse is 5 cm, which is 5 square, is equal to our opposite. Our opposite is 4 square plus the adjacent is not given, which is x. So here we say 5 square, this will give us 25 is equal to 16 plus x squared. So making x squared subject of formula, we have that x squared is equal to 25 minus 16. So our x is equal to 25 minus 16 will give us 9. So our x is equal to square root of 9. And square root of 9 is 3. So x, therefore our x is equal to what? 3. So which means this side of the chord is 3. But we are asked to find the length, which is AB, not just part of the chord. We are asked to find from this point, from this point to this point. That is AB. We are asked to find what? The length of the chord, which is AB. And we have gotten MB. Our MB is equal to 3 cm. And remember, initially we said that line MB is equal to line AM. That is to say, whatever value we get in MB will still be the same value we get in AM. So if here is 3 cm, it means that here will also be what? 3 cm. So for us to get our AB will simply be 3 plus 3, which is what? 6 cm. So our length, the length of the chord, which is AB, is equal to